My name is Rob. I'm a particle physicist, a university lecturer, and I'm the school's resident scientist. Yep, science was one of them, but actually maths as well. I think this is something maybe people don't always appreciate about science, is that all sciences have quite a lot of maths in them. So I love maths. Maths is sort of what first actually got me interested in physics. Physics has the most maths of all the sciences. But yeah, maths and science were my favourites. Although I loved history as well. History and English, which I have to because my mum is an English teacher, but mostly science and maths. So what led me to become interested in science is the fact that science is in everything. It's about discovering how the world works and investigating what's going on in nature. So it touches every single aspect of our lives. It touches every aspect of the universe. So I would say a better question is, why is anyone not interested in science? It's something you have to be interested in because it's fascinating and it's about everything. But specifically, I had a really good maths teacher here at KES, a fantastic maths teacher who got me interested in maths. And from that, I got interested in physics. And physics over the other sciences because I would say it's the most fundamental. It asks the most important questions of how did the universe begin? What will happen at the end of the universe? How did life evolve on Earth? That might sound like a biology question, but actually if you go back far enough, it's basically a physics question. Physics touches everything from black holes to molecules to fire to plasma to anything you can think of. It's all physics. I would say you've got to work hard. You've got to get good grades, not just in science, but also in maths. The most important thing, though, about being a scientist is just to be curious. It's about asking questions and don't be afraid to be geeky and to have people think you're a little geeky. There's nothing wrong with that. You know, when you get older, being geeky and being interested in science, it becomes cool, even if in school, well, I don't know, people think it's cool in school as well, I think. But work hard, keep your curiosity, that's the most important thing, and absolutely, every single day. The universe is enormous. In our galaxy alone, there's something like 100 billion stars at least. There's over 100 billion galaxies in our universe, and there's so much we don't know. I mean, for example, dark matter. Dark matter makes up over 90% of all the stuff in the universe, all the matter, but we've got no idea what it is. We know that it's there because of the way it helps the galaxy stay together and it makes the galaxy spin the way it does, but we've got no idea what kind of stuff it's made of. And as a particle physicist, that's kind of in my job description. I want to zoom in on matter and figure out, okay, there's atoms there. Well, what are those atoms made of? Well, they're made of protons and neutrons. What are they made of? They're made of quarks. And what are the quarks made of? Well, we don't think quarks are made of anything smaller. They are the smallest thing in that kind of matter. But when we ask the same questions about dark matter, we hit a brick wall and we don't know what it's made of. So that's a really big mystery in physics. So there are different models. It's still an open question whether the universe is infinite and whether it will continue growing forever. A lot of it depends on how much matter there is in the universe, the kind of density of stuff. There are other forces at play, one really mysterious one called dark energy, which we think has a sort of inclination to keep the universe expanding at an accelerating rate. So it's an open question. It seems like things are kind of almost very finely balanced right in the middle, where it could go either way. They could keep growing forever and ever, or it could sort of collapse inwards and squash back down into a singularity like there was at the beginning of the universe in the Big Bang. We call this the Big Crunch model, where gravity sucks all the matter kind of back in and it ends up collapsing and goes sort of almost back to where it started. But we don't know. We don't know is the answer. So the full power of the sun is an interesting question. There are these hypothetical megastructures that we've obviously never seen, but they've been hypothesized by a guy called Freeman Dyson. This is called the Dyson sphere. Now, this is hypothetically the limit of how you could harness the entirety of the energy from the sun by building a kind of sort of megastructure around it that, essentially like a solar panel, absorbs the light energy that comes from the sun, but it's surrounded and takes all of it in. Now, What we would need all that energy for, I don't know. I can't really think of anything. But we already harness the energy of the sun in solar panels, and in our bodies we harness the energy of the sun. The vegetables that we eat and the vegetables that the animals we eat consume are all, grown via sunlight. That's energy from the sun coming directly into our food chain and into our bodies. Ooh, that is a good one. Well, a common misconception they have in movies, if you watch films, is that when you see something blow up in space, it makes a sound. Now, of course, it wouldn't make a sound because sound can only travel through a medium, something like air or water, any kind of gas or liquid or even a solid. But in space, there's vacuum, there's nothing. So you would hear nothing in space, if there was an explosion, which would make films a little bit more boring because, spaceship would get blown up and it would just be complete deathly silence. But that is one of my bugbears with science fiction films. Ooh, so that's a really good question. So if you look at galaxies today and you look at the light coming from galaxies, they have a kind of reddish tinge to them. Now, that means that they are moving away from us very quickly. And if you look at basically any galaxy, on average, from the Earth, you will see that they all pretty much look red, or on average, they all look red. Now, that means that every single galaxy that we can see is moving away from us. Now, if you trace that backwards, where did they begin? They began all in one single point. And we call this point in space where they began, the Big Bang. So we think that all the matter in the universe sort of spontaneously kind of arose about 13.8 billion years ago at this moment in time that we call the Big Bang. So it's from tracing back the motion of the galaxies today that appear to be expanding from a common center. They must have started out somewhere else in the middle a long time ago. So we don't really know what exists inside a black hole, no. If you take the collapse of a star, which is what forms a black hole, and you take it to its ultimate conclusion, all of that matter that formed the star gets squashed down essentially into a point. And we call this point the singularity of the black hole. But just because we have a name for it doesn't mean we know anything more about it than that. It's a point in space where the laws of physics as we understand them completely break down. So the black hole has this singularity at the center that violates, or well, it doesn't violate, but it completely confuses the laws of physics as we know them. And this is shrouded in the so-called event horizon, this one-way system that you can enter, you can fall into a black hole, but once you enter, you can't get out. So we know that when something falls into a black hole, it can pass through the horizon. If you're the thing falling in, you will experience, not much actually as you pass through the horizon. But once you hit the singularity, all bets are off. We don't know what goes on at the singularity. That's something we need a quantum theory of gravity to understand. And we don't have that. If we did have that, or if I knew the equation for that, I wouldn't be sat here, I'd be off getting my Nobel Prize, but that's not going to happen. So, right now, we only know of one place in the universe where life exists, which is here on Earth. If we discovered life on another world, it would completely change what it means to be alive on this world and to be human. Scientists love data, and right now we have a data point of one, which is the Earth. We think that all life on the Earth evolved basically from a single common ancestor, from a single event. So if we could understand how life might have evolved on other worlds, it would tell us a lot about how biology works and how biochemistry works on our planet. I think another thing it would teach us on a maybe more philosophical level is that being not alone in the universe shows us that we are all one human species. We live on one planet, this tiny little pale dot, as Carl Sagan called it, in a fairly unremarkable solar system, in a fairly unremarkable galaxy that is one of something like 100 billion. So it would give us, I think, a sense of unity, and the boundaries between countries and things like wars and fighting over resources that are not scarce on our planet would seem crazy. Because it is crazy that humans do that. We are all one species, we're all one people, and that's what I think it would teach us. I think one of the most amazing things, which is a well-known thing, and it's something that's been known for some time, is that over 90% of all the atoms in your body came from the heart of a dying star. When stars die, they undergo, or very large stars, when they die, they undergo a process of supernova, where the nuclear fuel that keeps them supported against the pull of gravity inwards disappears and they collapse. And this collapse, this implosion, triggers an explosion. And it creates some of the heavier elements that we have in our body. So iron, for example, the iron in your blood is really only formed inside the dying heart of a very, very old star. But heavier elements as well that we find in our body are formed in these supernovae. So 90% of all the atoms in your body are from exploded stardust, which I think is a really remarkable thing to think about. And, it puts in perspective the incredible chain of events that lead to you and I sitting here today on this planet. We've got generations of dead and dying stars exploding their guts across the cosmos has all led to us being here, and billions of years of evolution on the Earth as well, from single-celled life up to complex organic beings like us. So it's that incredible billion years of history, of cosmological and geological history, that leads to us sitting here today, and it starts in the heart of a dying star. That's what I find fascinating. So it's quite difficult. There's a speed limit in physics that is very hard. Well, I say very hard, it's basically impossible to get around, and that is the speed of light. So light travels at 300 million meters per second, and nothing we know of in the universe can go faster than that. In astronomy, we measure very large distances using light years. Now, a light year is how far, not how long, how far light travels in the span of 1 year. So the nearest star to us, Proxima Centauri, I might get the number wrong, is something like 3-point-something light years from us. Now that's in our galaxy. So that means traveling at the speed of light, it would take you over 3 years to get there. So getting to our nearest galaxy is going to take you even longer than that. And given that we can only travel at such a tiny fraction of the speed of light, I think it's impossible with the technology of today, and it's very unlikely to imagine how technology in the future could even allow us to travel those distances in several human lifetimes, let alone in one human lifetime. So Mars is an interesting one. Scientists believe that in the very distant past, Mars was very much like the Earth. What happened on Mars is that it, for some reason, lost its magnetic field. So in the Earth, the magnetic field is generated by motion of liquid hot iron inside of the Earth's core. And when Mars lost that, it meant it became exposed to the solar winds. This is high energy particles coming from the sun. And essentially, that solar wind stripped Mars of its atmosphere. And if you lose your atmosphere, it means any liquid water you might have on your surface will just boil away, it will evaporate away. And so Mars became functionally uninhabitable. In the very distant past, I think it's reasonable that life could have existed on Mars, but we've seen no evidence of it yet. And the circumstances that led to the circumstances that led to life beginning on the Earth are still very much not understood by us. It could be that these circumstances are so astronomically unlikely that life really has only ever emerged once on one planet in our galaxy, or possibly in the universe. So it's certainly not a given that life ever emerged on Mars as well. As a deviation, one place we're currently looking for life is using the Europa Clipper mission. So this launched last year, and the goal here is to try and fly a satellite through one of these plumes of water that is shooting off the surface of Europa, which is one of Jupiter's moons. Now, this is an interesting moon because it has a liquid water ocean under a sort of thick sheet of ice. And one of the most important things you look for when you're thinking about whether life could exist on a planet is liquid water. So Mars, I think, certainly doesn't have life on it now. Whether it did in the distant past, we don't know. But if I was going to bet on anywhere in our solar system that might contain life other than the Earth, it would be Europa, one of Jupiter's moons. So I think it's conceivable in the next 20 to 30 years we might discover the nature of dark matter. This is something that, in a way has been a long time coming. And a lot of really smart people are working on it. It's still a really interesting research field. And it's something where it might just be the right time, where sort of theory and experiment and observation are kind of coming together, where we might figure out what's going on with dark matter. Something I would love to see solved, which we won't see solved, I don't think, in my lifetime, perhaps in your lifetime, I don't know, is the quantum theory of gravity. This is the quantum version of Einstein's laws of gravity, and that would be interesting because it would unlock a lot of the mysteries of what's going on inside a black hole, and that's something, just from my personal interest, I'm really interested to know more about. So, one of the arguments people often give here is that, again, there's something like 100 billion stars in our galaxy, over 100 billion galaxies in the universe, and we know that most stars you see in the sky do have planets around them. So, you've got something like a 1 with 22 or 23 zeros at the end, planets. Now, that's a huge number of planets in the observable universe. But there are processes, chemical processes, physical processes, whose probability of happening is so vanishingly small that it could conceivably only have happened once on one of those 10 to the power of 23 planets. We won't know until we discover it. I think that's the key thing. There are some interesting theories as well about how life could sort of cross-pollinate across different astronomical bodies. This is this idea of panspermia, where perhaps, say, for example, an asteroid hits into the Earth, which I hope won't happen, but it knocks off a chunk of Earth, and that chunk of Earth has within it some biological molecules, perhaps even some very, very resilient microbes, something like a tardigrade, which is something called a water bear, the really interesting looking microbes. And these microbes then drift across space, and they land on another planet, or the rock that they're attached to lands on another planet, and suddenly you've populated life on another world. Again, we've seen no evidence that that happened in the Earth's past. It could be, of course, hypothetically, that life originated elsewhere in our solar system and was knocked off of that planet and then shot onto our planet. And that's where life came from. But it's very hard to investigate because you're talking billions of years in the past and you're talking about microbes which don't form fossils. So it's very hard to look at that early evolutionary history of life on the Earth. Gosh, I don't know. No is probably my honest answer. I think I've never seen any evidence of extraterrestrials or things that can't be explained. The human mind is very amenable to suggestion and being misled, so we can't always believe what our eyes see. So, yeah, I've never seen anything convincing that tells me aliens have been here.